Hi viewers, today we'll see about trigonometrical identities exercise 21A for ICSE grade 10. So trigonometry is primarily about the right angles and the three sides and the relationship. So the important ratios here are sine, opposite, sine theta, here the theta is the angle. So we talk about the relationship between the sides of the triangle and their angles. Next ratio is cosine, that is cos theta is adjacent by hypotenuse, sinus opposite by hypotenuse. Next is tan, tangent, it's tan theta, which is sine by cos theta. Next, it's important to recollect the reciprocal identities which you learned in your earlier grades to solve this exercise. So, sine A is equal to 1 by cosecant A. Cosecant can be written as SEC as well as CSE. Next, cos A equal to 1 by secant A. Tan A equal to 1 by cot A. So with this and few more identities, we can solve this exercise easily. First question is, prove secant A minus 1 by secant A plus 1 equal to 1 minus cos A by 1 plus cos A. So we can take LHS, secant A minus 1 by secant A plus 1 equal to, secant A can be written as 1 by cos A as per reciprocal identities. So 1 by cos A minus 1 by 1 by cos A plus 1. Just by taking LCM, 1 minus cos A by cos A by cos A by 1 plus cos A by cos A. Both cos A we can cut. So the answer is 1 minus cos A by 1 plus cos A, which is same as RHS, equal to RHS. Hence, this is a proof. So hence, proved. We need to write at the end. Next question 2. Prove 1 plus sin A by 1 minus sin A equal to cosecant A plus 1 by cosecant A minus 1. So here we can take your RHS, cosecant A plus 1 by cosecant A minus 1, which can be written further as cosecant A is a reciprocal identity is 1 by sin A plus 1 by 1 by sin A minus 1. Again by taking LCM, 1 plus sin A by sin A by 1 minus sin A by sin A. So we can cut both sin A. So answer is 1 plus sin A by 1 minus sin A, which is LHS. Hence proved. You need to write hence proved at all the proof questions. Next question 3. Prove 1 by tan A plus cot A equal to sin A into cos A. So we can take LHS 1 by tan A plus cot A. 1 by tan A can be written as sin A by cos A. Cot A is a reciprocal of tan, so cos A by sin A. It's just the reciprocal. Now we have to take the LCM. Sin square A plus cos square A by cos A sin A. Sin A or cos A, order doesn't matter on multiplication. As per Pythagoras theorem identity, sin square A plus cos square A equal to 1. This is one of the Pythagorean identity. We do have two more. Answer is sin A into cos A, that is RHS. Hence, proved. Prove tan A minus cot A equal to 1 minus 2 cos square A by sin A cos A. So here we can take the LHS. Tan A minus cot A. Tan A can be written as sin A by cos A minus, it is reciprocal, so cos A by sin A. By taking LCM, it becomes sin square A minus cos square A by sin A cos A. And we already know the Pythagorean identity, that is sin square A plus cos square A equal to 1. So sin square A is 1 minus cos square A. This is what we are going to substitute now for sin square A. 1 minus cos square A minus cos square A by sin A into cos A. So there are two cos square. So 1 minus 2 cos square A by sin A into cos A. So that is the RHS. Hence, proved. Next question 5. Prove sin to the power of 4A minus cos to the power of 4A equal to 2 sin square A minus 1. So sin square A whole to the power of 2 is same as sin to the power of 4. So we can write it this way. This is of form A square minus B square. So the formula is A plus B into A minus B. So A here is sin square A. B is cos square A. So it is written in the as per the formula A plus B into A minus B. Sin square plus cos square A. Cos square A can be written as 1 minus sin square A. That is sin square A minus 1 plus sin square A. So which means 2 sin squares minus 1. Same as RHS. Hence, proved. Next question 6. If you see 1 minus tan A whole square plus 1 plus tan A whole square is LHS. A minus B whole square and A plus B whole square. So by expanding the formula, A square 1 plus tan square A minus 2 tan A plus 1 plus tan square A plus 2 tan A. A square plus B square plus 2AB. So 2 tan A and 2 tan A will cut. So it's only 2 common to 1 plus tan square A. And 1 plus tan square A is secant square A. 1 plus cot square A is cosecant square A. These are also the identities. So here it's a form 1 plus tan square A, so which can be written as 2 secant square A, which is the RHS. Hence, proved. Question 7. Cosecant to the power of 4A minus cosecant square A equal to cot to the power of 4A plus cot square A. So by taking the LHS, cosecant to the power of 4A minus cosecant square A, it can be written as common is cosecant square A minus 1. RHS, same way we can write cot to the power of 4 plus cot square. We can write it as cot square A common, cot square A can be written as cosecant square A minus 1 is what is cot square A, as per the Pythagoras theorem identity. So this is cosecant square A. The second part is just cosecant square A. So LHS is equal to RHS now. Next question 8 is secant A into 1 minus sin A into secant A plus tan A equal to 1. Let's take the LHS. Secant A can be written as 1 by cos A, 1 minus sin A. Secant A is written as 1 by cos A. Tan A can be written as sin A by cos A. So this is a form 1 minus sin A by cos A into LCM is same, so 1 plus sin A by cos A. So 1 minus sin square A by cos square A. Sin square plus cos square we know is 1. So this is cos square A by cos square A, which is 1, which is the RHS, hence proved. Next question 9, prove cosecant into 1 plus cos A into cosecant A minus cot A equal to 1. So cosecant is reciprocal, so 1 by sin A plus, 1 by sin A into 1 plus cos A. Again cosecant is 1 by sin A minus cos A by sin A. That can be written as 1 plus cos A by sin A into 1 minus cos A by sin A. So it's a form A plus B, A minus B. So it can be A square minus B square. That's what is written on the numerator, which can be written as sin square A. So it is 1. Next question 10, prove secant square A plus cosecant square A equal to secant square A into cosecant square A. So by taking the LHS, we know secant square can be written as 1 by cos square A plus cosecant can be written 1 by sin square A. By taking LCM, it becomes sin square A plus cos square A divided by cos square A sin square A. Order doesn't matter in multiplication. And we know the numerator sin square A plus cos square A is 1 as per Pythagorean identity. It's 1 by cos square A into sin square A, which again can be written as, for reciprocal identity, secant square A into cosecant square A. So just by knowing few identities, we can solve this exercise very easily. Next question 11, prove 1 plus tan square into cot A by cosecant square A equal to tan A. We know the other two Pythagorean identities are 1 plus tan square A equal to secant square A and 1 plus cot is cosecant square A. So 1 plus tan can be written as secant square A into cot A by cosecant square A. Cosecant is reciprocal for sine and secant is reciprocal of cos. So by now we are familiar with all this. Dot implies your product. Cosecant can be written as 1 by sine square A. So that is 1 by cos A into sin A into sin square A, which becomes sin A by cos A. So sin A by cos A is tan A. That's the RHS, hence proved. Next question 12, if you see, prove tan square A minus sin square A equal to tan square into sin square A. So tan square can be written as sin square A by cos square A minus sin square A. So by taking LCM, it becomes sin square A minus sin square A into cos square A divided by cos square A. Sin square A is common in both, so 1 minus cos square A divided by cos square A. Here 1 minus cos square A is sin square A. So sin square A into sin square A divided by cos square A. So as per the RHS, I'm just rewriting it. Position doesn't matter in multiplication. So 1 minus cos square is sin square as per Pythagorean identity. And I'm rearranging as per the requirement of RHS, as it's just a multiplication. So sin square by cos square can be written as tan square A into sin square A. That's RHS. So by just knowing the identities, you can just play around to get whatever way we want. Question 13, prove cot square A minus cos square A equal to cos square A into cot square A. So LHS can be written as cos square by sin square, that's cot, minus cos square A. So by taking LCM, cos square A minus cos square A into sin square A divided by sin square A. So cos square A is common in both, 1 minus sin square A divided by sin square A. Since I want the RHS, you look at the RHS, its cot is there. That's why I'm just arranging them accordingly. So cos square A by sin square A into cos square A. 1 minus sin square is cos square. This is cot A, cot square A into cos square A. That is the RHS. So towards ending of equation, you just see how the RHS is. Accordingly, you can arrange. This is a multiplication. So sin square A position is completely based on the RHS. Question 14, cosecant A plus sin A into cosecant A minus sin A equal to cot square A plus cos square A. So by taking LHS, cosecant A plus sin A into cosecant A minus sin A. This is a form A plus B into A minus B. So which is A square minus B square. So cosecant square A minus sin square A. Cosecant square is what? 1 plus cot square A. Sin square is 1 minus cos square A. So this 2 1s will go. It's going to be cot square A plus cos square A. Minus into minus is plus, which is RHS. Hence proved. Next question 15. Prove secant A minus cos A into secant A plus cos A is sin square A plus tan square A. This is again a form A minus B into A plus B. So we know the formula is A square minus B square. So secant square A minus cos square A. Secant square can now further be written as 1 plus tan square A, and cos square can be written as 1 minus sin square A. So 1 plus tan square A minus 1 minus into minus is plus sine square A. 1 and 1 goes off. So tan square A plus sine square A. That is RHS, hence proved. Next question 16, prove cos A plus sin A whole square plus cos A minus sin A whole square is 2. So this is a form A plus B whole square and A minus B whole square. We need to expand it, which is A square plus B square plus 2AB. So cos square A plus sin square A plus 2 cos A sin A. Same way the next one is A minus B whole square formula. So by applying it, cos square A plus sin square A minus 2 cos A sin A. So these two will cut. It's going to be obviously 2 cos square and 2 sin square. One and the other here. So 2 cos square A plus 2 sin square A. So by taking 2 in common, it's going to be cos square plus sin square A, which is 1 as per Pythagoras identity. So 2 into 1 is 2. That's the RHS, hence proved. Next question 17, prove cosecant A minus sin A into secant A minus cos A into tan A plus cot A is 1. Just by applying all the reciprocal identities, 1 by sin A minus sin A into 1 by cos A minus cos A, tan is sin A by cos A plus cot is cos A by sin A, which can be written as 1 minus sin square A by sin A with LCM, 1 minus cos square A by cos A, sin square A plus cos square A divided by cos A sin A. Sin A cos A or cos A sin A, both are same. Position doesn't matter in multiplication, which is cos square by sin A into sin square A by cos A. All these identities we have seen in early problems. And sin square plus cos square A is 1. 1 by sin A cos A. So we can cut sin A and sin A. One more sin A and sin A. Same way cos A, cos A. One more cos A, cos A. So the answer is 1. That's the RHS. Hence proved. Next question 18. 1 by secant A plus tan A equal to secant A minus tan A. So in LHS, we can just multiply by secant A minus tan A by secant A minus tan A, which is actually 1. So we're just multiplying. So that becomes secant A minus tan A by secant square, because it's a form A plus B and A minus B. So A square minus B square, secant square A minus tan square A is 1 as per Pythagorean identity. So this is also 1. 1 plus tan is secant. So secant minus tan is 1. So the denominator is 1. So the answer is secant A minus tan A, which is the right hand side. So hence proved. Next question 19, cosecant A plus cot A equal to 1 by cosecant A minus cot A. We need to prove this. So to the LHS, we can take cosecant A plus cot A multiply it and divide it by cosecant A minus cot A by cosecant A minus cot A, which is actually 1. So it is again of form A plus B, A minus B. So A square minus B square. Cosecant is A and cot is B. So cosecant square A, it's A square minus B square actually. So cosecant square A minus cot square A divided by cosecant A minus cot A. And the numerator can be written as 1 as per Pythagorean identity. It's 1 plus cot square equal to cosecant square. So cosecant minus cot is 1. So 1 plus cot square minus cot square equal to cosecant A. So that's 1. We can conclude it in 2 ways. So we can solve in 2 ways. 1 plus cot square A is cosecant, or cosecant minus cot is equal to 1. Either ways it proves the same. Next question, 20 secant A minus tan A by secant A plus tan A equal to 1 minus 2 secant A tan A plus 2 tan square A. So by just taking the LHS, secant A minus tan A by secant A plus tan into secant A minus tan A by secant A by tan A. So just you're multiplying by 1, it is. So both are minus only. So this is secant A minus tan A whole square. It's by secant, this is again A plus B and A minus B. So A square minus B square. Secant square A plus tan square A. Top is of numerator is of form A minus B whole square. So secant square A plus tan square A minus 2 tan A secant A divided by the numerator 1 plus tan is secant. So secant square minus tan square A is 1. So the denominator is 1. Secant square can be written as 1 plus tan square minus 2 tan A secant A. Order is as per the RHS. I'm just rearranging it. Within multiplication, it doesn't make any difference. So that is 1 minus 2 secant A tan A plus 2 tan squares are there. So 2 tan square A. That is the RHS. Hence, proved. Hope you like it. If you find this useful, please do share with your friends and subscribe. Thank you.